Hello, everybody. This is going to be a rare video where we don't start with a word problem or anything to introduce this topic. The reason is because you've already had this topic introduced to you. This is solving systems of linear equations. We've been doing this. We draw two lines, and we see where they intersect, and we look at the point of intersection. However, there are times when solving it like that doesn't work. We still want to do the same thing. We still want to find the point where two lines intersect. But what happens if we have equations like this? Y equals x plus 6.1. Okay, great. So I have to go up to 6.1, and then I have to use my slope of, oops, magic pen, error. I go to 6.1, and then I have to use a slope of 1. So I'm going to go left. I go down 1, left 1, and I've got a point like that, and like that, and like that, and like that. I'm going to connect that dude. Okay, get me arrows, and I'm going to do it more or less like that. Great. Only problem is, I'm sure some of you already realize it, these might not be exactly in the right spot. And let's look at what happens on the next one. I'm going to do the next one in red. Okay, and I go to negative 1.4, which is right about here, and my slope is negative 2, so I'm going to go to the left again. I go left 1, up 2, or up 2, left 1, and I have something like that, and then I do it again, up 2, left 1, something like that, up 2, left 1, something like that. I'm going to connect this with a line. I need arrows, yep. Okay. Can anyone figure out what the problem is? Okay, I'm sure many of you got this, but what in the world is that point right there? I have absolutely no idea what point that is. It looks like something close to maybe negative 2.7 comma 3 point, I don't know, 8, but I have no idea. So clearly solving by graphing doesn't always work. The good news is, however, we have a better way of doing this. This is solving by substitution. Now, because graphing can be inefficient or approximate, we need this second way. Another way to solve it is by solving by substitution. Substitution allows us to create one variable equations, which we know how to solve. Okay? There's nothing to write down on this slide, so let's just go to this next one real quick. I warn you, try to pay attention, but this will not all make sense until we go through an example or two. So don't worry if you get lost, just keep following with me. And after a couple of examples, you can come back to this slide right here and try to figure out what it all means. Okay, so step one, if you are not given a variable already alone or isolated, you want to find the easiest variable to solve for or to get by itself or to get alone. Okay? Don't worry about what we're doing yet. It will become clear. Let's move on to this problem. The next. Okay, so we're going to start with this example right here that we just figured out we can't do by graphing. So we want to get one of these variables alone. Can anyone figure out what variable would be easier to get by itself? If you picked y, you're right, because we're already given those by itself. So we have gotten y alone. We only need to get it alone for one equation, but it's actually given to us alone for two, so we have even more choice. Okay, so that was step one. On that problem, it's already done for us. We've gotten the variable y alone. The next step is to substitute the expression into the other equation and solve for the variable. Copy down those words. Don't worry about the fact that many of you have no clue what I'm talking about right now. You will when we do this. Okay, I'm actually going to go on and after this, and we're going to do step two. Okay, so I have the first equation here solved for y. I have the second equation solved for y. I'm just going to, here's what I can do now. Once I know that y is equal to x plus 6.1, then what I can do is I can take this x plus 6.1, which is equal to y, and I can substitute it in for y in the other equation. Okay, so let's look at what that looks like here. what we're going to get is this x plus 6.1 takes the place of y, and so I have x plus 6.1 equals negative 2x minus 1.4. Notice what happened. These y's are now gone. All I have is one variable. Granted, it's on both sides, but I now have an equation that I can solve by combining like terms. So now let's go back to step 3 on your previous page. Substitute the numerical value you found into either equation. And, oh, I'm sorry. We have not finished step 2. I'm jumping ahead. Once we do this, we need to solve this guy. Let me see if it's actually here or not. No, it's not. So I get to do this by myself. Cool. Yay for math. All right. So we need to combine all of this. What we're going to do is we're going to add 2x to both sides. Great. I've got 3x plus 6.1 equals negative 1.4. Now I need to get x by itself. This is a standard two-step equation at this point. Subtract 6.1, subtract 6.1. Negative 1.4 minus 6.1 is going to be negative 7.5, and that's going to equal 3x. Still not done. I need to divide both sides by 3. Divide by 3. Divide by 3. I get that x is equal to negative 2.5. Now I'm done with step 2. I have found the value of x. Now let's go back to the previous page, and let's look at step 3. Step 3 tells me that once I have the value of one variable, I'm going to substitute that number I just found into either equation and solve for the other variable. And then I will have my solution. Okay? So there's nothing there you need to copy down. So let's go on to step 3. I've already solved this equation. I should get that x is negative 2.5. Great. And now what I do, now that I have x is negative 2.5, I just need the y value. Well, I can pick either one of these two equations, either y equals x plus 6.1 or y equals negative 2x minus 1.4. I picked the first one because it looks a little easier to work with, but either one will give me the correct y value, the correct y value, because remember, I'm solving for the point where they intersect. So they're both going to have the exact same x and y value at that point. So I put in negative 2.5 here. Negative 2.5 plus 6.1 is 3.6. So am I done yet? No, I don't box y equals 3.6. What I'm going to do is box my x comma y. My x was negative 2.5. My y is 3.6, and that is my solution. So if I go back to my graph from page 1, I have found that the point of intersection is negative 2.5 comma 3.6. Let's go back and see if I guessed right. Negative 2.5 comma 3.6. Oh, I'm sorry. I used the magic pen instead of the regular pen, but I had actually guessed that wrong. I had thought that this was something like negative 2.7 comma 3.8. That's what it looked like. Turns out that I was not exactly correct. I was close, but I was off by several decimal points. Might not matter if you're trying to do something silly, but if you're trying to send a rocket to the moon, being off by 1 decimal point is the difference between getting to the moon and getting 7 people to die in a fiery death. All right, so what we're going to do then, I'll leave this for you to do. I want you to check to see if that equation or that solution we just came up with, that negative 2.5, 3.6, negative 2.5, comma 3.6. See if that actually is the solution by plugging this first guy in for x here and here, okay? And then plug in 3.6 for y here and here, and see if they check. They're going to, but I want you to do that as good practice because you need to know how to do that on your own. And then we're going to do a couple more examples. So solve the system using substitution. Remember, step 1, I need to first substitute one equation into the other after I get one variable by itself. Notice I have this variable by itself, so I don't really have a lot of choice. I need to substitute this x minus 1 in for the place of y, okay? So when I do that, I plug this x minus 1 into y because that's what y equals, okay? And then, so what I have is 2x minus 3 parentheses times x minus 1 equals -1. Don't forget this equals -1, otherwise you won't have an equation. From there, I'm going to go to step 2, and I'm going to solve. So I get that 3 times x minus 1, quantity x minus 1, remember I have my distributive property, -3 times x is -3x, -3 times -1 is +3, and so I have 2x minus 3x plus 3 equals -1. I combine my like terms. 2x minus 3x is -x plus 3 equals -1. And then subtract 3 from both sides. I get that -x equals -4, which is the same thing as saying x equals 4. Okay? Now that I have solved for x, I just plug it into either equation. So here we actually have this, we're going to wind up with the same answer. I'm just going to show you how you could do it on either one. If I plugged it into the first equation here, I get that 8 minus 3y equals -1, which means, oops. Oh, well, I'll just write it in. I get that 8 minus 3y equals -1. I subtract 8 from both sides. I get that -3y equals -9. Divide both sides by -3, divide by -3, divide by -3. I get that y is 3. And so I wind up with the equation, the solution 4, 3. On the second one, I do the same thing. I plug in 4 for x. I get y equals 4 minus 1. So I get that y equals 3. Clearly, this one over here is the easier one to plug into. And you can just kind of get that by the fact that that's the easier looking equation. So if you have one that is already y equals, that's usually a good one to plug in for, but either one will give you the right answer. So what you need to do, then write down your solution, 4, 3. Notice you get the same thing on both equations. So that is your solution. All right, and then you're going to check to see if 4, 3 works. You get 4 there, 3 there. 2 times 4 is 8. Minus 9 equals -1. 8 minus 9 does equal -1, so it checks there. I'm going to plug in 3 and 4 for y and x here. 3 equals 4 minus 1, so 3 equals 3. I'll just write it in there. 3 equals 3, and you know you got the right answer. Let's do one more problem, and then I'm going to set you guys loose. So the first one, I need to, step 1, solve for one variable. What do you know? They're both already solved for y. So I have my choice of which one to use. I'm going to choose this one here. I'm going to take x minus 3 and replace it for y in the other equation. This gives me x minus 3 equals -x plus 5. Perfect. Now I just solve. I need to get my x's to the same side, plus x, and I get 2x minus 3 equals 5. Next step, plus 3, 2x equals 8, and so clearly x equals 4. Great. I'm not done yet, though, so I'm going, oops, that's not what I meant to do, clearly. I'm going to take everything, I'm going to group it, I'm going to shrink it all down so I can come back up, and I'll bring it back. But I now have x equals 4. Now what I need to do, I need to plug this x equals 4 into either of these two equations. Which one do I pick? Well, the one right here, the top one, looks a little easier because it doesn't have a negative sign in front of the x, although it doesn't really matter. Either one will give you the same answer. I'm going to plug it into the first one, though. Y equals x minus 3. I'm going to plug in x for 4. Y equals 4 minus 3. And so y equals 1. It's just that easy. I am done. My solution is 4, 1. Great. I purposely put that pause in there to see if anybody was going to say, but Mr. Duncan, you didn't check your answer. I didn't hear anybody. I'm hoping you said it at home, but I didn't hear anybody here say that, so I'm not sure. What we need to do is we need to check this answer, 4, 1. I need to check that to make sure it is a solution of both the first one and the second one. So y equals x minus 3. Let me change my color. Y equals x minus 3. and y equals negative x plus 5. I need to plug in and check my work. So y, 1, equals x, 4, minus 3. Is that correct? 4 minus 3 is 1, so 1 equals 1. Cool. Y, 1, equals negative. Do not forget this negative sign. Negative x means negative the value of x. The opposite of what you have here. We started positive, so we're going to end negative. Negative 4 plus 5. Well, negative 4 plus 5 is 1, so 1 equals 1. Cool, I got it right. Excellent. Oh, I guess I do have one more problem before I turn you guys loose. So if you are done, if you've got this completely, you can stop listening. You can do this one on your own. Or if you want a little tiny bit more practice, we can do this one together. I'm going to do it one way or the other. So I need to, step 1. Let's do this a little bit more systematically. Step 1, solve for one variable. I'm going to pick y. Solve for y. Check, I'm done. Okay. Step 2. Plug in to other equation. Okay, so I'm going to plug this guy here into that guy there. Okay. Step 3, or no, step 2 was actually solve. So now I'm going to solve this. I get negative 2/3 x equals negative 3x minus 7. I know some of you right now are freaking out because there's a fraction. Don't worry about it. We know how to deal with these, don't we? So we need to get these both to the same side. So plus 3x plus 3x. So I'm gonna do the rare step of rewriting this without actually combining. Negative 2/3 x plus 3x equals negative 7. The reason for this is because we still need to get this 3 into fraction form. Well, what's 3 as a fraction with a denominator of 3? It's 9/3. So what I'm going to do is negative 2/3 x plus 9/3 x equals negative 7. Negative 2 plus 9 is 7, so I have 7/3 x equals negative 7. Again, some of you see the fraction. You're like, great, I understand that part, but I'm freaking out on what to do with x. Well, to get rid of a fraction times a variable equals a number, just multiply by the reciprocal, 3/7 on both sides, 3/7. Look what happens. The 3's reduce to 1. The 7's reduce to 1. So I am left simply with x equals negative 7 times 3/7. But we all know that this negative 7 and 7 have a common factor of 7. So the 7 becomes a 1, the negative 7 becomes a negative 1. And now I'm just going to multiply across negative 1 times 3. And I get that x equals negative 3. Great, I'm done. No, I'm not. Okay, so that's step 2. What I need to do now, I'm going to group that, shrinky dink it. I've got that. My studio audience today is finding this funny. I'm wondering if it's coming through. It might be. That's my studio audience if you hear giggles in the background. All right, so we've got x equals negative 3. What we're going to do now is plug this. I don't even know. Is this step 3 by now? Anybody? Is this step 3 to plug it into the other equation? Okay, step 3. Clearly, I've done this so many times I don't use steps anymore, but you need to. Step 3, solve for other variable. Solve for other variable. And so what I'm going to do, I'm going to plug this negative 3 into one of my equations. Which one looks easier to me? Probably the one without the y-intercept. So this first one, even though it has a fraction, it doesn't have a y-intercept. So I'm going to do that one. Y equals negative 2/3 x. Y equals negative 2/3 times x. But what's x? X is negative 3. Hey, this is convenient, almost like these numbers were picked to work well. Negative 3 and 3 are going to reduce. I've got 1 and negative 1. So I have y equals negative 2 times negative 1 is just positive 2. And I box it and I'm done, right? Right? No. Okay, I need to put it as a coordinate pair, negative 3 comma 2. And then what I need to do is I need to check that. So step 4, check it in both. You know what, you guys have a video, so you can pause this if you need to. I'm going to erase all of this work now. Okay, negative 3 comma 2 is the only thing I need. Okay, negative 3 comma 2, I'm just going to check this in both equations. So I have this equation here, and y equals negative 2/3 times x. So now I plug it in. Y is 2 equals negative 3 times x is negative 3 minus 7. This is 2 equals negative 3 times negative 3 is 9. So 9 minus 7. I get 2 equals 2, and the people rejoice. On the next one, I have y, which is 2, equals negative 2/3 times negative 3. By this point, everybody should say, hey, those are going to reduce. That becomes a 1, that becomes a negative 1. So I have 2 equals negative 2 times negative 1, which is 2. I got it right. The people rejoice. I am done with this video. It is now your turn, as they